let me continue with the next problem. So, the next problem is like this. Determine the moment of inertia and radius of gyration. It is the fourth problem, I guess. Determine the moment of inertia. Determine the moment of inertia and radii of gyration, plural word, radii of gyration of the area shown in figure, of the area shown in figure about the base AB, and the centroidal axis parallel to AB. This is the question. Let me write down the diagram, then you will understand. So, the diagram is like this. So, we have a rectangular portion here. So, this is 20. Then this and this. This is 30 mm. This is also 30 mm. This is also 30 mm. And then this is the shaded region. So, be careful with this. So, this is the shaded region. Here we have two questions. Okay. So, one is determine the moment of inertia and radii of gyration of the area shown in figure about the base AB. This is the base AB that they have given. So, that is the first question. The second one is the same moment of inertia and radii of gyration, I need to calculate it about the centroidal axis parallel to AB. So, parallel to AB centroidal axis means IXX, only IXX I need to calculate. There is no need to calculate IYY and all. Okay. So, first let me take up the first question about the base AB, that is moment of inertia about the base AB. So, first one, to find moment of inertia about base AB. So, please remember one thing, whenever they ask you people to calculate the moment of inertia with respect to the centroidal axis, we need to calculate the centroid without miss. But here they are asking us to calculate it about the base AB. So, whenever they ask you people to calculate it about a particular point, there is no need to calculate the centroid. So, whenever they ask you people about some other point, it is always easy, because there is no need for me to calculate the centroid. I will not be calculating the centroid at all now. So, first what I will be doing is, I will be calculating the area of the different portions, that is it. So, observe here, this entire triangle, I will be considering it as 1, and its centroid lies exactly at the center, that is G1. Next, the centroid of this particular triangle will lie somewhere over here. I think you people know that for a symmetric triangle from the base, it is at a h/3 distance. So, I will be calling this as G1, and this is the first one. Second, I will be calling this as a rectangle. The centroid for this, it will be G2. So, totally we have two diagrams in it. Okay, let me calculate the area of that. So, to find the area, so let me go calculate the first one. So, what is A1? So, A1 is nothing but the entire triangle. So, it is half into base. So, base value I forgot to write. So it is 100 mm. Please make a note of it. It is 100 mm. So it is half into base into height. So what is the total height? 90. So what is the value that we will be getting it? So it is half into base into height. So 50 into 9. So 5 9s are 45. So I think 4500. So next, let me go with A2. So A2 is breadth into depth, 20 into 30. So it is 20 into 30 I will be going with. So it is 600 mm square. Sigma A and all, I don't need it as of now. So now let me go with, I am calculating it with respect to find the moment of inertia about the base AB. So it is IAB. Directly I am taking it a moment of inertia because no need to calculate the centroid. So now what I will be doing? So first observe, this entire triangle is resting on the base AB because I need to calculate it about this point AB itself, and this triangle is resting on that particular base. So that's why for this particular triangle, so you should use the formula IAB. I want everyone to go back to the tabular column that I have given. There I want you people to check out IAB. What is the formula? So let me check it out. What is the formula for IAB? It is BH cube by 12. So it is BH cube by 12. Please remember, I am not using IXX formula nor I am using IYY. The only reason is the entire triangle is resting on the base where they have asked us to calculate the moment of inertia. So that's why IAB formula for the triangle is BH cube by 12. So it is BH cube by 12. So what is B? So breadth is 100, B into H cube. So what is that BH cube by 12? So BH is 90 cube by 12 plus AH square. So A into H square. Observe here, I want everyone to concentrate here. Area I know it is 4500. I want everyone to concentrate here. What will that H square becomes? Whenever the entire diagram is resting on the base, okay, and I need to calculate it about the base, H will always be 0. Please remember this. Or else you do one thing, don't consider this value at all. Okay, so now plus, so not plus, minus. Why minus? Because I need to deduct this rectangle out of it. Minus. Now, even though they have asked us to calculate the moment of inertia about the base AB, this rectangle base is not resting on the AB. Therefore, don't worry, for this rectangle, you normally go with the value because it is parallel to this. AB is parallel to this line, so IXX formula I will be going with. It is BD cube by 12. So, no doubt, I hope there is no doubt for you people. Only when the entire diagram is resting on the base, then only you need to go with the base formula, and that AH square will become 0. But here for a rectangle, so it is not resting on the base, so it is parallel to the base. So you can go with IXX. It is BD cube by 12. What is that B? It is 20 into D cube is 30 cube by 12 plus area is 600 into, what is that H square? Because they are asking us to calculate with respect to AB. So it is the distance between the centroid of the Kernson diagram till the reference axis. So what is this distance? It is 30 by 2, that is 15 plus 30. So 15 plus 30 whole square. So if I solve for this, the value of AB, it will be, the value of AB, it will be 4.815. It's 4.815 into 10 power 6 mm to the power of 4. So please remember one thing, whenever they don't ask you people the centroidal axis, there is no need to calculate the centroid. Here they have asked us to calculate about the base. Triangle is the one which is resting on the base. So I need to use the base formula for the triangle, and AH square it will become 0. But for that rectangle, the rectangle is not resting on the base. So you go with the normal formula. Then why IXX formula? Because I want to calculate with respect to the base. Base parallelly I need to calculate, that is x axis. That is why this particular formula. Any doubts in that? Now we should not stop at that stage. Determine the moment of inertia and radii of gyration. So I will be calculating KAB. So what is that KAB? It is nothing but IAB by capital A. So what is that IAB? So it's 4.815 into 10 power 6 divided by, what is that capital A? Just now we have calculated. Capital A, sigma A, I want it. So it is sigma A, A1 minus A2. Why minus? Because I need to deduct this rectangle. So it is 4,500 minus 600, that is 3,900 mm square. Let me substitute that particular value. So what will be the value that I will be getting there? So it is 35.14. This value is 3,900. It is 30, just a moment. It is 35.14 mm. Only this much if you want to calculate it about the base. Now the important thing comes into picture. Let me move on with the second question, second part of the question. I am done with the first part. Let me move on with the second part. So what is that second part? So we need to calculate, determine the moment of inertia and radii of gyration of the area shown in figure about the base. We are done with it. And the centroidal axis parallel to AB. It is the centroidal axis parallel to AB. Now what I need to do? Centroidal axis they are asking. So first I need to calculate the centroid. There is no other go. So for that reason what I will be doing, the same diagram I will be keeping it. Okay. So I will be rubbing this particular heading. So to find the moment of inertia about the centroidal axis I will be marking it. About centroidal axis. About centroidal axis. I need to calculate it. Yes or no? So this is the second question that I am taking it. So the area will be same. So to find the area, A1, A2, sigma A, everything will be same. But this step, from here onwards, it changes. So what is that? I need to calculate the centroid. So you people know that it is having y axis of symmetry, but I will not be marking it. Because they have not asked us to calculate the moment of inertia about both the axes. Directly they have asked us to calculate only about the axis parallel to the centroidal axis, parallel to AB. So what I will be doing is, I think you people know that where the centroidal axis lies, for a, I don't know at what distance it will lie, for time being I will be marking it like this. So let us calculate that. So we need to calculate it. So to find y bar, I am not in need of x bar because this they have not asked us. They have asked us for this. So next heading. So to find y bar. So what is the formula for y bar? Y bar is equal to A1 y1 minus A2 y2 whole divided by sigma A. So then what is y1? So let us try to calculate it. So now y1 is nothing but it is the distance between the centroid of the concern diagram. Observe here, it is the distance between the centroid of the concern diagram till the reference axis. If I want y1 I need to touch this one. So it's a triangle. For a triangle, what is this centroidal distance? I think you people remember it is h by 3. Please remember, you need to remember the centroid formula. For a symmetric triangle from the base, the centroid lies at a distance of h by 3. So it is 90 by 3. That is 30 mm. Similarly, let me go with y2. So what is that y2? So y2 is nothing but it is the distance between the centroid of the concern diagram till the reference axis. What is this distance? 15 plus 30. 15 plus 30. So how much is that? 45 mm. Let me substitute everything back in that. So y bar is equal to A1. A1 is 4500 into 30 minus A2 is 600 into 45 whole divided by. So it is 3900 sigma n. So after solving it, we will get the value for y bar as 27.69. It is 27.69 mm. So the value that you people will get is 27.69 mm. Let me mark that particular value there. So from here to here it is 30 mm. Now I want y bar as 27.69. So I have already marked it. So this y bar is equal to, it's 27.69 mm. Soon after getting this, let me mark the remaining distance. So what is this distance? 90 minus 27.69. 90 minus 27.69. So let me calculate it. 90 minus 27.69. 90 minus 27.69. So it is 62.31. It is 62.31. 62.31. So let me leave it as it is. So now let me start calculating the moment of inertia. So next one, to find moment of inertia parallel to the base AB, it is nothing but Ixx. So I need to calculate Ixx. The formula is same, Igx plus AH square, no doubt in that. So what is Igx? The first diagram, it's a, what it is? It's a triangle. So for a triangle, I am not calculating it about the base, I am calculating it about the xx axis. What is the formula of moment of inertia of a triangle about xx axis? So it is bh cube by 36. So please remember, it is bh cube by 36. So it is b, breadth is 100, h cube, bh cube, h cube is 90 cube by 36 plus, so what is that area of the first diagram? So it is 4500 into, so what is that h square? It is the distance between the centroid of the concerned diagram till this axis. Okay, so now what is this distance? H by 3, total is 90. This distance is h by 3, that is 30. 30 minus 27.69. 30 minus 27.69 whole square minus, I need to go with one more. So the second one is a rectangle. It is about xx axis BD cube by 12. So what is BD cube? So B is, it is 20 into what is D cube? It's 30 cube by 12 plus area is 600 into, so from the centroid of the concerned diagram till the reference axis. I want you people to concentrate here. So what is this total distance? 62.31. Yes or no? So I need to deduct this particular distance. So it is 15 plus 30, 45. 62.31. 62.31 minus 45 whole square. So after solving it, so you people will get the value Ixx is equal to, just a moment, Ixx is equal to 1.82 into 10 power 6. 1.82 into 10 power 6 mm to the power of 4. Here they are asking us to calculate the moment of inertia. I have calculated it. Also they are asking us to calculate the radii of gyration, that is radius of gyration. That is Kxx is nothing but equal to Ixx by capital A. So what is the value of Ixx? It's 1.82 into 10 power 6 divided by capital A, it is 3900. So after solving it, the value that you are going to get is 21.63. It's 21.63 mm. See, there is one more concept. Okay, I mean, this is one more concept that I have explained you people about the base. In the same problem, I have explained you people how to take it about the base and how to calculate it about the centroidal axis parallel to the base. Okay, any difficulty in understanding this?